Hello, can you hear me? Is it clear?
Yeah.
Cool. I'm here for like 45 minutes. I don't really know what I'm going to talk about, so I'm either going to waffle or hopefully you're going to take me in a direction that's interesting to you. So I don't want this to be like a normal academic talk where the presenter speaks and there's questions at the end and then you grill the person. Grill me all the way through, please. Ask as many questions as you can as I'm talking, and I'd like to be able to take it in a direction that's interesting to you. Otherwise, it may as well be a video. And I've travelled all the way with a ridiculous non-train things to be here, so please take advantage of that. And then I'm also I'm slightly tired because I've just gone on an epic journey. I've been away from home for a week now, so I left Sheffield, where I live, went to Utrecht, where I gave a presentation to 800 computer science students. It was an amazing conference they organised themselves, talking about the similar kinds of things I'm doing here, which is amazing. Then I went to Antwerp and gave a masterclass at the Royal Conservatoire of Belgium in Antwerp for jazz musicians, which is pretty crazy. And these are jazz musicians that are using my system and other systems, but predominantly my system, for their expressions in jazz. And actually last year, 3 or 4 of them, or maybe I think 5 of them, graduated with their performance, not with saxophone or piano or guitar, but with Sonic Pi, which I found pretty crazy cool. And then we did one of those algorave things where I performed at the nightclub, which was super fun. And but actually what was really interesting to me was like most of the performers there doing the music, live coding the music with the software I'm talking about, weren't computer scientists or programmers by background. They were musicians by background. So we're really starting to see this intersection of music and computer science really coming full circle, where I remember I did this thing where I did this performance at the Royal Albert Hall with loads of kids. It was wicked. We did like a live coding quartet. It was me, 2 young kids, and their live coding teacher, along with like 4 orchestras, 5 wind bands, 4 choirs. It was amazing. It was organised by one of the music hubs. It was Lyric Hammersmith, and they were really trying to target children in schools who wouldn't normally have an opportunity to do music. And so there was a whole bunch of funding from the Arts Council to set up orchestras in schools where there weren't orchestras and wind bands where there weren't wind bands. And they hired a composer, Charlotte Harding, to create a new piece of music for them all to practice and perform together. And they brought them all together to perform in the Royal Albert Hall. It was amazing. And there were a bunch of really interesting things came out of this for me. One was like the practicalities was super fun, because obviously the live coding thing was like the last thing was just stuck on the end. It was like a token, like let's put a bit of weirdness on, right? Let's be modern. I guess it's like the same kind of thing where you see having a DJ with an orchestra. It's like that's funky and cool. It's a bit edgy, but actually it's not at all. But and also that comes back to the time when I was in giving a prize ceremony actually for a prize which I didn't win. And I was talking to the top 2 people from the Royal Associated Board of Music. And they're people who do the grades, like grade 5 piano, grade 8 piano. And I was talking to them about the live coding thing, and they seemed interested. And I said, so when are we going to do grades for music? And they said, well, actually, we've just introduced jazz. And I'm like, it's 100 years late. It's like, yeah, so we're in this context. And so we were just stuck on the end. And I remember they had all practiced and practiced and practiced together. And it was like, there was like the day before the performance was when they wanted to integrate the live coding bit. And so we went to this practice hall, which was just across the road from the Royal Albert Hall. And the conductor was like, 3, 2, and I was like, no, I can't do that. I've got to be the time. Because my software, I can't press go like that and be in time with everybody else. So that was a really interesting. The conductor did not like that. I've since fixed that, and you can do things like that with the Sonic Pi, but that was a problem. And then the other issue was after the performance, right? So these kids were doing syncopated synthesizers. They were doing really cool, interesting musical structures, like the kind of structures that the jazz people are really interested in Antwerp. And so I was ready to have this interesting conversation. Finally, live coding's in a traditional musical environment. Finally, it can be accepted and we can talk about it peer-to-peer. No, so many people were telling me it's not real music, and it was deeply, deeply frustrating. So yeah, that was really interesting to see that actually starting to change now, and I think that's really, really, really good thing. So now I'm here after the Netherlands, Belgium, in Milton Keynes. That's a great epic end. to that adventure. So, yeah, that's where my head is right now. And yeah, I created this thing called Sonic Pi to deal with the issue of finding ways to engage children in computer science. And if we talk about computer science and human interaction, I mean, and my journey of it, actually, maybe it makes sense to talk about overtone. Yeah. So this is where I started, and I think for this kind of environment, I think this is these interactions between objectives and engagements in community, I think, are what I'd like to talk about. So the goal of Overtone was to build the most powerful live coding synthesis environment I could imagine as a programmer. It's like, I'm going to use my programming skills as a wizard, and I'm going to make this amazing piece of software. It's going to be great. You're going to be able to make any kind of performance you can imagine. I was using something called Super Collider, which is an amazing synthesis engine, and building a new language on top of that engine using a programming language called Clojure, which has some really interesting properties. It's a Lisp, so it's super flexible. It's got some really nice ideas about concurrency. And so I was thinking about building big shared instruments that multiple people can use at the same time, and did that. And I was actually live coding with my brother-in-law all around the world, where we were both actually working on the same instrument at the same time, performing together, using the same state. So there wasn't two separate instruments that were mixed together in the output. We were working with the same instrument. And that was super fun. We did a whole load of, we actually created this band called Meta X. I think their website's still up. Still pay for it. Here we are. And we did like loads of gigs. It was cool. And all over the place. I probably can't read that, but there's a list of gigs, right? And but the thing with Overtone was that I didn't actually understand really what I wanted to do at that time. I hadn't understood it. And I thought that as a programmer, as a mathematician, I guess, the aspect, the mathematician hat on, I was trying to build the most expressive language I could build that allowed me to do as much as possible. And so when I was designing the system, I was thinking about what could I do to improve the expressibility? How could I make that better? Imagining the live coding system as a tool, like a vehicle, like a drive around, and thinking about the range of the vehicle and the kind of terrains it could cover, and making that as large as possible. And that was all well and good, except for it was missing a critical element, which was it was super hard for anyone to use. It was really, really niche. It meant that in order to do anything with this system, you had to learn synthesis design, which is a huge, complex thing to even get your head around, because you can't just play a note, you had to design a note. That was already like a big, massive hurdle. And then you had to design the note in a really niche programming language, which no one really knew or used. There's a very few number of people. But also, and this is the really important point for me that I learned, was about time. Time can mean so many different things. When we talk about music and time, we often mean in time and at time. But here, in this case, I'm talking about time as how long did it take me to not just think about an idea and then think about how I could express that idea in the system, the expressibility of it. But then, how long did it take me to actually realize that idea? And that hadn't occurred to me to be a really important thing to emphasize. And that didn't happen until, so I was doing this, I was very happy with this, and then got a really cool opportunity to work on a project aimed specifically initially at the Raspberry Pi computer. It was a 3-month project to engage kids in code. So the initial plan was to try and take Overtone and get that running on the Raspberry Pi. That didn't work because of technical reasons. And so I then built the simplest thing I could build. It was funny because I thought that the remit for the project was to build something to perhaps teach, to explore the idea of teaching kids how to code and to see what would happen. 3 months felt like a very ambitious, short period of time for that. And in the first meeting, actually what it was clear what they wanted was they wanted someone to build, well, me to build a system to teach kids how to code, to have it running, to find a teacher, to go into a school, to teach computer science with it, to evaluate it in 3 months. And so it was like, well, that was such a tight turnaround period that that really forced me to focus on being as simple as possible. So the first version of this software took 2 weeks to build and didn't do much at all. And then once we found the teacher, a wonderful teacher called Carrie Ann Philbin, she was teaching in a school in London, I went with her and we talked about what we were going to teach, and we looked at the curriculum and we figured what it was. And then I would then teach that lesson with her, and then we would evaluate that, and then we would talk about what we're going to teach next week, and then I would go home and write a new version of the software that had the features to teach that lesson, and we iterated over that. And that was all good and well, and I was working on this system as like a toy, really. This is like, there's some money to work on a cool thing for kids, and it's really interesting to do, but actually, my heart is here. Because this is the wizard's programming language. It does everything. It's amazing, super powerful. And why would I want to do anything else other than this cool stuff? It's got all the best programming language stuff, and Lisps and whatever, and meta-programming out your ears. And this is just like a toy little system to go into schools and teach kids how to code. So it was interesting from a pedagogical perspective, but it wasn't interesting for me as an artistic perspective. Until I got this opportunity as part of one of the projects we were working on, a really fabulous project, engaging with artists, to create a music video with Sonic Pi. We actually had a whole bunch of artists make amazing videos, and one of them was me, weirdly. So I was like, okay, what do I do? And I had to make this music video. And I was really scared about this, quite worried about it. And I left it to the last minute, of course, as I always do with everything. And then sat down, so okay, I've got a week left to produce this thing. So I sat down, locked myself into a room, and made a piece of music. And that week changed my life. And I think that's that pivot I'm talking about now, as I think is the message I would like to talk about in this keynote. Because in order to make that music video, and I actually think it's on the MetaX website, actually. Yeah, this is the one, yeah. Maybe you can even see elements of what I was doing. Do we have sound? Hold on, let me just... Yeah, do we need to turn it up? Or maybe you can fiddle with that, I'll fiddle with this. So we are. Oh, it's good, it's going. Yeah, you can see actually, there's me in the, it's quite dark actually, in my living room. We've got this little small projector I bought with the budget, because I need to make a video, so the plan was to project the code on random places. And it was all done on a Raspberry Pi, and I was sitting there, and I had left my laptop, my coding environment, my phone in another room, and I just sat there for a week projecting the code on the wall. Because I didn't have a monitor at home. Because all I had was a laptop, and I had to do this thing on a Raspberry Pi. And I knew if I made a piece on a very fast machine and tried to make it run on a very slow machine, that was going to be a recipe for disaster. So I'm going to actually do the composition on the slow machine to make sure it's going to work, right? And so just purely for practicality reasons, I was doing this weird projection thing, which actually now I'm still doing, 10 years later. And that changed my life because I realized that this crappy environment I'd built for teaching kids how to code, and I actually did a lot of effort into figuring out how to make it simple for the teachers to teach and simple for the children to understand, to make the cognitive sort of complexity as simple and friction-free as possible, purely for that the educational school context. And actually, all those, and I had thought of those as limitations, as just not interesting musically, but interesting from a pedagogical perspective. But in this context, when I'm making this music video, turned out that although this language was by far less capable in terms of a mathematical definition, a philosophical definition of expressivity, you can't make as many pieces of music, you can't make as much musical synthesis, you can't, if your vehicle, if this is a live coding vehicle for making music, you can't drive as far. But what you could do is you could come with an idea and make it real, if it worked within the system, much faster. Much, much, much faster. Because that was the goal in the schools. Because you only have an hour in a classroom, if it's a big lesson. And if it's a small lesson, you've got much less. And of course, then in that lesson, there's a whole bunch of friction about getting the children to actually listen. You've got to get them to sit down, you've got to get them to focus. All that takes time. So it was really trying to find a way, how do we get them to make the music as quickly as possible? And so all those decisions I'd made actually turned out to be really nice for this. And once I'd spent that week making this piece of music on this crappy Sonic Pi, it became the only thing I ever used since then. I didn't touch overtone at all since that week, because it was just so fun. And I felt like a musician, I felt expressive. And since then, I actually started practicing and rehearsing and streaming performances most days from there. I actually did YouTube video. This is one of the most watched videos I've done. Sam Aaron, Sonic, ambience. This piece here. And what's nice about this is that's in the same room, right? You just saw, but I've got a slightly bigger projector now, so that's pretty cool. You can't quite see, but I've got like a cool desk in front of me, which I'm coding on. It's all very dark and dingy. That's my ironing board. So every night I would set up this ironing board, the projector, set up the stuff, do the performance, and then tear it all down, because obviously that's the living room. I'm living in a very small house in Cambridge. So I started doing this all the time. And that then started to help me understand that what musical requirements would be. Like, because I was using the system, I was able to understand this. And then that turned into a really interesting sort of interplay between the requirements of the project and my interests, and actually more importantly, the interests of the kids. And we get to that now. So does this make any sense? I still haven't had any questions, which is quite disappointing. I'm going to judge you all by the number of questions, right? 10 points a question, okay? Because really honestly, take me in the direction you want to go. So let's have a look at the system. Has anyone ever played with Sonic Pi before? Yeah, cool. It's important to point out, actually, that as with all with computer science, nothing is new. Nothing here is new. There's tons of other really cool live coding systems around and other approaches to make music. So I'm not claiming any novelty in anything I'm saying. All I'm talking about is my particular focus, which has been always about, well, since Overtone, education and teaching kids how to code. And that turns out to have really interesting properties, which I'll go into now. So with Sonic Pi, the goal was to be able to make interesting music, but that's not really the goal. The goal is to have something that the kids can just make some sounds as quickly as possible. So actually, for many people, this has been their first program. In fact, actually, in Utrecht, actually one of the students came to me and said, I learned to code through Sonic Pi. When I was at Cambridge, I gave a workshop and a lecture, a part of the Science Festival last year. And one of the students from Cambridge was helping out with the workshop, one of the computer science students. And he said, Sam, I came to one of the summer school things you did when I was a kid. And that just inspired me now to do computer science here. And he was actually studying at university. There was an organization teaching minors, retraining them into computer science. And I saw a talk where these minors were showing Sonic Pi, and this was their first code they had written. So the goal really here is to be as simple as possible. We have a function called play, we have a note number, and higher the number, the higher the note, and lower the number, the lower note, right? That makes sense. So the kids say you need two commands, right? So, and that's play and sleep. And then once you've got these two commands, you can make melodies. And what's really interesting is that with these two commands, you can pretty much make any melody you've ever heard or will hear. Most of Western music is really pitch and time, and we have both of those things represented here. There's obviously a ton of other stuff like timbre and expression and the length, the duration of the notes and all that kind of stuff. But in its core, you have the ability to make Twinkle, Twinkle, Little Star, Daft Punk, Bach. Like, you can represent all those things, and kids can represent their ideas this way. I mean, I remember teaching my niece when she was 6 this, and I showed her this, and she'd written 100 lines of code in her first program, because she just kept writing play and sleep, play and sleep. She was lovely. I said, that's amazing. And she said, I've not finished yet. And she was carrying on. And this is critical, right? So this was the goal of the computer science thing. We've got sequential programming, we've got functions, we've got abstractions, we've got arguments. So you can teach a whole ton of stuff, actually, already with these two commands. And it turned out, actually, that teaching computer science isn't hard at all. Building a system to represent the kind of core content of the UK, in particular, curriculum for computer science, is not hard. What's hard, I know that's a really bold claim, but really what's hard is engaging them. Finding a way to them to give a monkeys about it, like to care, you know? And so that turned out to be the really interesting problem. And it turned out to me this actually ended up being a massive conflict between the interests of the students, my interest actually doing my own performance later on, and the goals of the project, and obviously the funders as well. And because they wanted to teach computer science, and I learned actually that wasn't that hard, but the engagement bit was the hard bit and the interesting bit and the actually important bit. And to make them engaged, I had to start adding, guess what, musical elements. Things that aren't on the computer science curriculum, but things that the kids wanted to do. So, so this was actually quite happy. For the funders were very happy with this. This was great. So we can do loops. I can do like a loop this. Cool. So we've got like an algorithm now. That's nice. What the hell is an algorithm? There we are. So now we've got a loop. Cool. We can do conditionals and yada, yada, yada. And I'm not going to go into those details because they're not actually that exciting. They are if you want to teach computer science, but we're not here. We're musical people looking at the range, the plethora of ways to interact with music, with computers. The remit of the workshop did say broad, so I'm going to go down that as well, because I'm going to include a social perspective of what this is as well. So this is where we were. So that the kids would then start saying, well, that sounds rubbish. That's not very interesting. How do I make it sound cooler? So we started introducing different synthesizers. Here's like a Prophet-like synthesizer. Let's play like note 40. Make it louder. Make the release time longer. That's nice. But then like things like this, like we want to. Oh, I can't. And be able to change the timbre of the note. None of those things really were on the computer science curriculum, but they were really interesting for the kids. So adding things like the cutoff values, adding the release times, like these options to actually start to take that and make it a bit more interesting, a bit more expressive, were things that I saw as essential to the success of the project, but the funders didn't. So this was an interesting, like a way of a conflict, a friction. And then, so now we've got, and what's also interesting here from an interaction perspective is note that there is some surprising interaction styles here. So this is a program, and every time I press the run button, it's actually creating a new musician, essentially, in the system. And they're overlapping. It's not waiting for the previous program to complete before the new one starts. So we have already this idea of concurrency, which I'll talk to very shortly. But that's just to bear in mind. So we're actually starting to think about programming languages slightly differently than traditional programming languages. Of course, then, fun to add like samples, because kids like to have like sounds which sound good, right? Because that's important to them. Obviously, for me, Amen break is let's have a loop. Amen. What was fun with this is that actually starting to think about like how do you take a sample like this and work with it in an interesting way. So obviously in the 80s, Dr. Dre took this sample and played it at half speed and rapped over top. So let's try that. So that was easy to add. Nice. And in the UK, a bit later, we were doing that kind of faster kind of stuff, playing with things like this. What do you think this is going to do? Oh yes, good answer. Yeah, so there we go, this kind of stuff. And so all these things, again, weren't on the computer science curriculum, but there were tools to maintain the engagement of the kids. Here's another one. What about being able to, people were taking the Amen break, obviously, and slicing it up with special magic audio scissors and rearranging it in all sorts of interesting ways. So what was a way to think about that in a way that you could just tell the kids how to do it, like without interrupting the class? Because this was actually the critical thing. So the teacher would say, today's learning objectives is sequential programming, right? And off they would do the thing. But there's always a couple of kids who that's dead easy for them, and they're already bored. And so they're like, how do I do something? And they'd usually ask musical questions. And so it was always about finding ways that you could go to those kids and give them a nudge and just show them a cool little trick that didn't interfere with the rest of the lesson, but then allowed them to maintain their engagement and still deal with the learning objectives. It didn't conflict. So these are all little ideas like that. So what are the magic scissors for loop Amen? Well, I thought, well, it'd be quite nice to be able to treat it like a list. So I have an onset option, which you can work through every energy onset of that sample. So it just does energy detection of the sample. And of course, then that's quite fun. If you add the loops, let's see, for a short amount of time, and now we're good. We can do like this, or like this. Well then, what I thought would be really fun is choosing a random one. And that's using a lambda to pick random ones. So this was an interesting thing, because we'd get to this point, we show them loops, and maybe they would do that, and then they would do something like this. And then they like sample bass drum house, seek for half a beat. I know. Yeah, that's pretty cool. Let's make this louder. And maybe a low pass filter on that. Yeah, cool. And so this would be so often, actually, in a computer science lesson with kids, I'd see this structure. I'd teach them a loop, and there'd be a couple of kids who'd like, oh, cool, I can do a loop, I can do the break, I can do a guitar thing, I can do a little synth thing, I'm going to do that and the drums. I want to play the drums and the bass, because everyone wants to play the drums and the bass. And so I remember going to this girl, she put her hand up, and she'd written essentially this code, 2 loops like this, very simple loops, and she'd run the code, and this is the way to learn Sonic Pi, by the way, if you want to learn it. Write the code, but don't press the run button. Imagine what it sounds like in your head. See if you can hear it in your head. And then press the run button, and then see if how wrong you are or how right you are. And through that approach of oh, I'm wrong, what could I tweak to understand where I'm at? So you start to get an understanding of the semantics, execution semantics of the system. And then the beautiful thing is, if you keep doing that for a year or so, you can reverse it. You can imagine sounds and see the code. And that's the cool bit together. So with that in mind, look at that code and imagine what it's going to sound like. And this is also like, when I give this talk like this, I'll show this to a bunch of like professional programmers and say this is an interview question, because this is an interesting, tricky question. What is it going to sound like? Where are the drums? Where's the arm end break? That's interesting. Now, just to emphasize this, if I swap the loops around, the order of the loops of the declaration, where's the kick drum? So this is an interesting problem. So this girl had this problem. She'd done these 2 loops, but she could only hear one of them playing. And she put her hand up, and I looked at her, and I said, I can see the problem here. You've got what's called a concurrency problem. Right? You've got a single thread of execution. A single musician, essentially, is created. When you press that run button and it goes pink, we create one musician, and that one musician starts at the top, and there's a loop, and loops are like black holes for program. They take the program and they just keep it. And so we end up going around that top loop forever. We never, ever, ever get down to that bottom loop, because loop is saying loop forever. So this is a problem. So to solve this, you can do weird, interesting weaving of the stuff, or you can use concurrency. You have 2 musicians, one playing the drums and one playing the bass, which is obviously the natural thing in a musical context, but is actually weirdly the unnatural thing in the computer science context, because whenever you mention threads to people, like, they stand back and they're a bit scared. But if you think about it in a music context, what's more natural? One person playing all the instruments at the same time, the kazoo and the drums and the cymbals, or having a band where you have one person per instrument. It's much more natural to do that. So I remember at the time, I said to her, oh, yeah, I can see why that's not working. The system can't do that yet. And she's like, oh, she was a bit confused. And then I went to the teacher and I said, this girl, she wants to play the drums at the same time as the bass. The teacher's like, yeah, that sounds cool. And I said, well, maybe we could teach that next lesson, and I can add some features to enable that to be possible. And she said, yeah, that sounds great. And then she said, is it on the curriculum? And I was like, ooh, no. And she said, well, sorry, we can't do it. I'm like, what? So I went to this girl, and I didn't say this. I wish I had. Well, I don't wish I had. It's funny, though, to think about it. I just said to her, sorry, you can't, and she was not interested. But I wish I had said, sorry, actually, if you want to do this, you're going to have to wait till you're 18. Because when you're 18, you still want to play the drums at the same time as the bass with code. You can go to university, and they will teach you concurrency, and you'll be able to do this. But I essentially just told her she couldn't do it, and she immediately got disinterested. She immediately looked out the window, and she was done. And that was tragic, because in terms of computer science and education in general, just finding a way to get the child to pay attention, to care, that is hugely hard. And then, not only were we doing this in this particular case, this girl had not only paid attention and listened to what we showed, and she was able to reproduce it and to do something herself, she'd taken it to a next level. She'd actually come up with her own interpretation, her own ideas. Oh, if I can play one loop, I can play multiple loops. That'd be pretty cool. And no one had taught her to do 2 loops, because that obviously wasn't possible. She'd done it herself. So she'd really imagined like a new place and gone to it. And so it's kind of like a little seed popping out the ground, fragile leaves popping out, like looking around. Oh, this is interesting. And I went over and I stamped it out. So sorry, it's not on the curriculum, not allowed to do it. The government say no. And so this was really a tragic thing. And so the whole of Sonic Pi's design was really about trying to fix that, trying not to have that be a problem. And so the cool thing about being a programmer and the cool thing about code as an interaction medium is that it's really malleable. Language is a really malleable thing. And so we can say we've got loops. Loops have been around forever, since we had like counters in programs and in instruction sets. But do we need to stop at loops, right? Is that where we're at in society? No, we can imagine our own kind of loop. So I created a live loop. And live loops have to have names. Sally, and this is Kate. And now, works as expected. And so when we go to schools to teach computer science, we just talk about live loops. That's in Sonic Pi. Hello? Hi, sorry. Yes?
Working. Oh, it's really working. Sorry to interrupt the flow, but I'm taking advantage of the fact that you said we could butt in. I was wondering if you ever did sort of do the opposite and take it to teach music? I mean, I guess you're always learning music, but is that ever the focus?
Well, that's what I'm saying. Like when I went to Antwerp, they're using Sonic Pi and other live coding systems, but predominantly Sonic Pi, to teach jazz. Yeah, and so that's really exciting to see. And when I gave a workshop there, the questions were just phenomenally interesting, and actually have led to a bunch of new features that are going to go into the next version to enable them to express their jazz ideas. So yes, but that's coming full circle and starting to appreciate that that the system is not just something for teaching kids to code, but actually starts becoming a natural instrument. Chris.
So you're talking about evolving the language over time and changing the syntax and semantics. Have you ever been in a situation where you introduced something new and broke backwards compatibility, or how do you approach that? I mean, what's the kind of policy?
I mean, one of the critical ways, critical aspects where that happened really, unfortunately, was with the randomization system. So Sonic Pi wanted to play with randomization. So if I have like a iteration, and I'm doing like a sample, loop amen, say, and I'm doing onset, pick, and sleeping for a small amount of time. So now notice that it actually reproduces the same sound every time. So this is by design. And this actually, weirdly, for artists, is they don't like it. They want randomization to be different every time. And I'm saying to them, no, you don't. And they say, yes, I do. I say, no, you don't. We have this argument. And they don't, actually. I'm right. Because if you have a system where it's the same every time, you can make it different every time easily. So they can have what they want, right? But if you have a system which is different every time, you can't easily make it the same every time. So actually having a deterministic system and setting the seeds to be the current time of day gives you the same kind of effect as a purely random system for all intents and purposes. It doesn't have the philosophical beauty of the library with all the books ever written and ever will be written kind of thing, but that's just philosophical nicety. It's not practically interesting or useful. And dealing with randomization as something which can't be held or touched is like trying to pick up water from a stream. You can't do it. You can appreciate its beauty, but you can't then take that beauty and perform with it, or take that beauty and share it with your friends. And so having the randomization system be deterministic seemed to be a really interesting property, because you can copy this code into your version of Sonic Pi, whichever platform you're using, and you will hear exactly the same drum riff. So when I implemented this, I switched the implementation of the randomization system. I essentially implemented my own randomization system, and that then meant there were a bunch of compositions I had before that were using randomization, which I couldn't recreate. And that was a tragedy. So, yeah, there have been times where backward compatibility has been a hit, but it's always been, I felt like, I try my best not to do it, but I also let myself do it if it introduces some interesting behavior, because the implementation of this randomization system is such that it can actually be ported to other languages and other systems. So any composition in Sonic Pi can actually be, in theory, be reproduced in other systems, because the randomization system has a specification, essentially, which can be re-implemented in other languages. Does that answer your question?
Yes, thank you.
Yeah, so only 10 minutes left, so I can keep talking about implementations and ideas. But in terms of this, I want to talk about the social stuff, because it turned out also, not only was it interesting to think about the design of the language and making that simple, and then adding features that were musically interesting but didn't interfere with the computer science lesson has been I spent a lot of time walking in fields, just imagining these things, and have all these ideas about what I could implement. And I would take it down and have a look at it and go, oh, yeah, that's pretty cool. And people suggest things, yeah, that's pretty cool. And then I was like, can I imagine implementing it into the system? No, gone again. Oh, yes, I can, cool. Does it tessellate well with all the features? No, okay, gone. So then I think again, can I implement this in the system? Yes, does it work well? Does it tessellate well? And then I would say, can I teach it to a 10-year-old child? Oh, no, gone again. So only the ideas that I felt I could teach to a 10-year-old child and have taught to a 10-year-old child have gone into the system. So that's been a real massive filter in terms of the functionality. So rather than like a musical system where you're trying to grow it to be as powerful as possible, which was essentially what I was doing with Overtone, this was a narrowing down kind of thing, and it ended up the things that popped out the other end were actually pretty fun and easy to use and had the properties I was describing before. And so that was really interesting. But then it was also important to talk about the social sort of placing of this, because if we think about it in terms of instruments, let's go down the musical route. Why do people pick up a guitar? Is it because it's a beautiful wooden object? I mean, for some people it would be, right? And when I give talks to computer scientists, they're the kinds of people, they're the equivalent of the people who pick up a wooden object because it's beautiful. And so they found computer science naturally themselves because they're curious mathematically or linguistically, and they've found computers and they've made relationships and friends with computers, and they're super cool to them. And they're not the people I care about, actually. I'm interested in figuring out how do we reach everybody else? How do we get to the people who don't normally consider themselves associated or adjacent to programming? And so if you think about the instruments as a way to actually solve this question, solve this problem, people don't pick up a guitar typically because it's a wooden object that's beautiful. They pick it up because they've seen Taylor Swift perform the guitar. They pick it up because they've seen Jimi Hendrix do amazing things. And like, whoa! So the virtuosity, the potential virtuosity of the instruments is clearly apparent. And the range of styles that you can produce with the instrument is clear. I mean, there's also many other reasons, like the fact that there's a whole set, multiple ways of learning. The whole approach to learning these instruments has been laid down and evolved over many centuries and eons in many cases. So I was thinking about this in the same way, like, how do we think about this? How do we get kids to care? And it's not just about making it simple and making it fun and making the language good. I can talk about that all day as a programmer. It's like, where's the Jimi Hendrix of this? Because if I could put a video of Jimi Hendrix, if Taylor Swift, I ask this at every conference I go to, but maybe somebody knows Taylor Swift. If Taylor Swift were to make a video or a track with live coding, there would be so many programmers tomorrow. And those programmers wouldn't be the ones that would normally find programming interesting. That's, to me, would be really exciting. So I'm like, this is where I'm going. Luckily, this is starting to happen, right? This is obviously me doing the weird thing, but there's a performer called DJ Dave. And she is based in New York. Here she is, here's her Instagram. So she's like a cool performer, but look what's going on here. Look, there's code behind, right? And this is a really good picture here. Here she is performing to that audience, and on the stage is my assistant. And those people are interacting socially interacting with computer science in a way that's not typical. They're not seeing people build a business app. They're seeing people making music and expressing themselves. And to me, that's really, really interesting. And I'd like to, I'm here all day, I've only got 2 minutes left, and I want to show a video for 3 minutes. Is that possible? Can I take 1 more minute? So I'd like to end with the latest video that she's made, because I think that really solved my problem. When I go into schools now, rather than have to convince kids it's interesting, I actually show them this picture, and they're like, whoa. And then I show them this video. So if I go to YouTube and type in DJ Dave Array, this to me is amazing. So I'll finish with this. There you go. So to me, that's like the amazing thing to see. So I'll just quickly summarize and say, engaging with artists, focusing on the real people, working with users directly, they're all really critical things. Thinking outside the box, trying to find ways that don't actually meet the goals, but actually meet the goals you see that are important, that you're learning on the project are important. And I'll finally say, I just want to say thank you very much to Alan Blackwell, really, for enabling all of this, because without him, I wouldn't have been able to get this started. So thank you, Alan. Thank you. Am I done?
Just to say that we can certainly have 5 minutes for questions, because we've got
Cool.
like half an hour.
And I'm here the rest of the day and here the evening for the meal as well, so it's fine for questions.
Thank you so much. Thank you for sharing about. I was aware of the project, but I never heard it so well explained. So thank you. Most of the programming languages, when somebody comes up with a programming language, the promise is that it's going to make it easier to do something, right? And that means it's going to be more expressive for a particular application or set of applications. I think this is an excellent example, and it really meets that goal, in my opinion. But I would love to hear your thought about what do you think is going to happen with LLMs for this particular application, right? With any programming language, you still need to learn that programming language. The promise of LLMs is you don't need to learn anything, and you can still make computers do some things.
Yeah.
So I would love to hear your thoughts.
I mean, large language models is something I could talk about for a very long time. I don't really understand them that well yet, so I'm still trying to get my head around them. But my understanding of them is that they're very good at doing patterning, like making something similar to things I've seen. And so I think from an artistic perspective, that's quite interesting, because you can generate a whole bunch of stuff in a sort of style that you want, and then you can then critique those. I think that's the critical thing with LLMs. You have to verify the output all the time. You can't rely on it. But if you don't need that output to be something you rely on for safety or anything critical, I think that's quite interesting. I think there's a tragedy potentially that's coming, in that these large language models are very good when they've been sufficiently trained. And so, for example, Python, there's a whole ton of programming examples of Python. Are we ever going to move past, if these LLMs become critical tools for programming, are we ever going to move past Python? Because if you come up with a new programming language which has some cool features, but doesn't have the corpus of data to generate the kind of results out of the LLMs, we're stuck in Python. So maybe we're fixed pointed now, which is a bit of a tragedy. But also that you can use LLMs with SonicPy, but the outputs are a bit crappy at the moment, so we need more data. But I think as a tool for generating interesting ideas, I think that they're kind of good for exploring. I've been having lots of conversations with ChatGPT about stuff, and it's often wrong. And I'm like, are you sure? It's like, no, actually, I'm wrong. Like, oh, okay, quite, figure it out. Yeah. But I'm happy to explore that further later on as well.
Is this on? Oh, it's on. Thank you, that was fascinating. As a non-programmer, I found this extremely interesting. And as a performer, I found the parallel with the kind of accessibility and simplicity of guitar as an instrument in comparison to many other classical instruments. What I find interesting is that I really found interesting the kind of discussion you had with regards to the fact that you had to simplify your system, and if simplify it's been accessed, and how that simplification was worrying you, and how that...
So what was the last word, sorry?
How that simplification was causing worry to you, because you were worried about actually being able to create something that was demonstrably interesting in the educational version of this. But what I find interesting also is how the guitar in itself, within pop and rock music, eventually became a tool for people who couldn't play anything, and they picked it up and started making noise. And actually that was a more of a stance, or a political stance, with regards to where music was going, especially guitar music. So I was just wondering if you can see this kind of level of access and simplification having an effect in the kind of music that live coding music produces.
Yeah. I think that to try and understand what you're saying, yes. I mean, the fact I saw in Antwerp these live coding musicians who were musicians primarily, who were jazz trained, perform, is really starting to see that happen. I think that guitars is an unfortunate comparison. It's an easy one to make, and I made it myself, and pianos are the same, but it's kind of cheating because guitars didn't just pop into existence. They've evolved over many hundreds of years of the use of the instrument, of the performance of the instrument, of the teaching of the instrument, and all those things. And so you end up this object we say now started these things, but actually that was the end point from a huge amount of iteration. And we're nowhere near that with these kinds of systems yet. So I think we could do the same thing, maybe in a few hundred years' time, or maybe that gets accelerated, I don't know, but certainly in the future we might see the equivalent of guitar in live coding systems. I don't think we're there yet. So yes, I think does that sort of help with what you're saying?
Thank you very much. Yeah.
More questions?
Yeah, that was a really great talk, and I suppose I'm interested in a couple of things, and one of them, following on the guitar analogy, is that there's a physicality to do with most musical instruments that makes sense in some way to people. Like you can understand it just by looking at it and feeling it. I mean, maybe bassoon is a little bit more complex, but there's a kind of certain physicality that lends itself to you being able to approach it, touch it, and feel it in a way that is obviously missing, or maybe missing is not the right word, but that's a difference between a musical instrument in a classical sense and something like this. So I'm wondering, like, when it comes to tangibility and when it comes to physicality, have you thought much in that kind of realm about how you might engage people through physical, I don't know, elements or ways to interact with the systems you are making? I guess that's it.
Yeah, I mean, so that's a really good question, and I think that's a contention that comes a lot. I imagine, though, when the harpsichord came along, similar questions were asked, because people aren't touching the strings directly with their fingers. There's mechanics touching the strings, hitting them. Levers are moving, and that's not real music because you're not touching the strings yourself with your fingers. You can't bend them. So I wasn't obviously there when the harpsichord was created, but I imagine there was similar kind of conversations about whether this was a real traditional instrument or not, this mechanical beast that was in this room. No, I'm not talking about I'm talking about the fact that the connection between you and the thing that's just producing the sound is more abstract. And here it's even more abstract again. And I think all that means is it just affords you different kinds of things. I think that when we need to look at it in terms of the context of this, when a DJ Dave's peers are using a lot of systems which exhibit exactly the same thing, where they're on the stage, they've got some knobs, they're twiddling, no one really knows what they're doing. There's a lot of removal. Often you don't know if they're pressing play or they're actually producing it live. So I think that the whole idea of live coding with projection of the code is really interesting because it tries to tackle that by communicating back to the audience the intent and the action and the goals of the performer in a way that isn't necessarily tangible. You haven't got like this physical connection with the thing, but you've got a conceptual connection with it. And I think that's just as important. And I think we start to then think about these kind of systems, not just as a tool which is a traditional instrument where the means for producing the sound is a physical object that you're holding, but also as a composer. And no one will challenge the musicality of a composer. And here we're actually mixing and matching at our will the extent to which the system is physical or conceptual and blurring those boundaries and mixing those up in an interesting way. So I think really it comes down to the difference between a violin and a harpsichord, and the difference between a saxophone and a trumpet. And there's going to be differences between all those instruments, and live coding is just another instrument that brings in composition and abstraction and language as another mechanism to interact with the audio, and gives you maybe less fine-grained control, but more macro control. And maybe that as an individual who wants to express themselves through music, maybe that's the space that you're happy with. And so I'm really always try to let people know that this isn't an attempt to replace violins. It augments it. And to go further on your question, like, of course, mixing in physical signals to the system is totally interesting. And Sonic Pi supports MIDI by default. and network messages, so you can have really fine-grained control. You can build your own instruments that are just controllers and work with the system trivially, if that's something you're interested in. And of course, then the interesting question is, and I do this in schools a lot, you give them a MIDI controller and they press the buttons and it doesn't make any sound. But they see these events on the screen and they're like, well, this is rubbish. Why isn't it not doing anything? You're like, well, what would you like it to do? And they're like, what do you mean? Well, you can choose. And that, to me, is the interesting thing. So it's not necessarily the physicality, but also it's the design, bringing the performer into the design decision.
And there's something about the immediacy of the maker is almost trick one thinking of it as an instrument as much as a composition.
There's both, yeah.
Exactly. So
You can, with Sonic Pi, with the play, sleep, and you can make a composition. You can press play and you can play it all. But with the live loops, which is what DJ Dave's doing, you can, and I didn't show you actually, the coolest bit is you can modify it as it's running, and you turn it into a performance that way.
Are we out of time, Simon? We're not out of time. Thanks so much, Sam. Just thinking about the battles with the curriculum authorities, and someone asked very reasonably, have you tried teaching music lessons?
Yes, we did.
So, of course, back in the day when we commissioned those videos, part of that project was also to go and teach some music lessons with music teachers in schools. That was, I guess, also 10 years ago. I just wondered if you might let us say something to the audience reflecting on what happened when we did go to teach music lessons using Sonic Pi. You might let us say a bit about that.
Yeah, maybe you might want to say that more than I remember. All I remember, whenever I worked with music teachers, typically, it was lots of gatekeeperiness about what was and what was. And when there wasn't gatekeeperiness, there was, the curriculum was already set and full. And so trying to get the teachers to even consider this as something they could even integrate with their lessons was really, really, really tricky. Whereas the computer science teachers were gagging for anything that could help them engage the kids. So they were really open to new ideas. Whereas the music teachers already had, we've got what works, we've been teaching this for years, we'll be teaching it for years. Like we're not going to consider anything new. So that was, it's almost like the speed of change for computer science was much faster than the speed of change, was more glacial for the music curriculum. So that was a really hard sell to get it in. I hope that rather than, with computer science, we try to go bottom up, like teaching the kids and get them engaged in creativity from the start, to actually start to and change the social perspective of programming to be one which is seeing programming languages as a tool for creativity, not just a tool for business apps. But maybe for music, it has to come top down. Maybe the people in Antwerp and are doing their performances in jazz, who are seen and recognized and understood and respected, that will maybe trickle down. And maybe that's the way in the future that might happen. Don't know. So is that suitable? Do you have anything else to add, Alan? Or?
No, I really need a break time, I suppose.
Yeah.
Well, maybe just final question.
Yeah, I'll make it quick. Sure. So I find fascinating this journey that you described, going from making instruments for the already curious and the already aspiring wizards and witches to making instruments for people who don't necessarily already know or care about this thing, and something that might grab their attention and pull them in. So this tension between instruments that look to extend the ceiling and instruments that look to lower the floor. And my question to you is, are these mutually exclusive design goals, or have you learned things that can bring those together?
Yeah, and I think this is still an issue for Sonic Pi. People can't see that it's possible to do both. A guitar is both. A piano is both. Like, I can teach any of you, if you've never seen a piano before, how to play notes on a piano in 2 seconds. All of you can play notes on a piano straight away. Of course, then you can see the virtuosity of amazing pianists and see the potential, but you've got a really low starting point and a really high thing. And I think that's because of the evolution of the design of the instrument and the teaching practices inherent. Whereas with technical systems, people don't think that's possible. And certainly it's hard, right? You need a lot of design. And I guess the funding isn't there. The business interests aren't there to do those things. People want sophisticated things that have a particular goal. But making something that is both those things, there's not much economic interest in making those kinds of things. It takes a weirdo like me to keep banging on about it for 10 years to be able to do it. And I think that, so when I go and give talks or show people things, or even like a lot of live coding musicians see Sonic Pi and go, well, that's really basic. It can't be that sophisticated. And they'll stop there at that point. Whereas the live coding systems look like the Matrix. There's all these things moving around like, whoa, that must be amazing. The complexity there must be, the potential is great. And they haven't seen through this. Actually, with sufficient design, you can do both. And that's always been a goal of Solid Pies, is to focus on the lowering the barrier to entry has been the critical goal, right, for creative experiences of code. So making it simple, making it cheap, making it run on low-powered machines, but also trying not to reduce the ceiling, trying to make sure that it's always possible. So that's why it's being taught at Royal Conservatoire of Antwerp in jazz, because it's got a ceiling high enough for the top-tier musicians learning jazz in university. So yeah, and I think the answer is continuous design, deep thinking, really trying to understand how you can simplify things in a way that tessellates with everything else in the system in a fluid way. And rejecting stuff that doesn't do that, not putting it in until you find a way that does. Chris?
So fantastic talk, fantastic project. I was just going to say, I don't want to eat into the break, but the workshop later, the Manhattan workshop, is going to be talking about a lot of the same kind of issues and accessibility of music and coding. So there's going to be an opportunity to talk with Sam, who's going to be at the workshop as well.
Manhattan's amazing. Definitely go to that workshop. Chris does an amazing job with that as well. But thank you.
So let me just say, and also, I think, Sam's probably got his laptop here, so if anybody wants to sneak in a 2-minute masterclass with Sam, you can always ask him.
Oh, absolutely, yeah. Or a 5-minute one, yeah. I can talk all day about this stuff.
So let's thank Sam.